Hello all. Today we are going to talk about calculus. So our course is zero level calculus, which will be needed in class 11. And this calculus has two parts. One is called differential calculus or differentiation, and second part is called integration or integral calculus. So in this part we are going to talk about this. Now calculus is very important branch of mathematics, which is developed by I guess Newton and Leibniz, and it has wide application. Okay, so we'll look at the basic of what is calculus and how we are going to use it in some context. Okay, now the idea is that this idea of differentiation is actually used to measure a rate of change. So this idea, whatever it is which we are going to learn, is used to find a rate of change. Okay, now so if you remember from the topic of graphs, that there is a concept of called function. Okay, now if you have a function, let us say we have a function y equal to, y is a function of x. Now this can be anything, right? Y can be x square or whatever, x plus 2, whatever. So if y is a function of x, then if you have a relation like this, then dy by dx is called a rate of change of y with respect to x, and this is also called derivative of y with respect to x. Okay, so this dy by dx is read in three ways. Okay, so this is dy by dx is called rate of change of y with respect to x. This is also called differentiation of y with respect to x, or it is also called derivative of y with respect to x. Right, now moving on, in one dimension you guys are familiar with x is a function of time, right, in one dimensional motion. So if you guys remember, like x equal to ut plus half a t square kind of thing, right? Now so x is function of t here in one dimension, or in two dimension also. If you have projectile or something, then x and y are somehow dependent on time t. So if you have a x as a function of time t in one dimension, then dx by dt is called instantaneous velocity. Okay, the word instantaneous is very important. So this is rate of change of x with rate. This is velocity is, we say, displacement by time, but actually the correct definition of instantaneous velocity, okay, at one instant is dx by dt, where x is position. So this is just like we pronounce this is the rate of change of x or position with respect to time. This will be called instantaneous velocity. And once you know velocity, then acceleration is rate of change of velocity. Okay, so acceleration in one dimension is defined like this, right? Now so let us be familiar with this thing first. Dy by dx, what it is called, and the analogy I gave you, like this is velocity and this is acceleration. We define it like this. Now let us try to understand what is this dy by dx, from where it comes. Right, now we know that if I have a graph, let us say yx, so we know that the slope is constant. Okay, any straight line will have constant slope, it will not change. But if you have a function like curve, so let us say yx, and we have a curve, that at different point the slope in straight line, the slope is fixed, which is nothing but this angle. But for a curve, at each point the slope will change. So let us say that there is a point, let us say P here and Q here. Okay, so let us label it P and Q, and this coordinate is, let us say, x and this coordinate is y, and let us say this is x plus delta x, and this is y plus delta y. Okay, so we have a function which is a curve. Okay, yx is a curve, and now here delta x, to understand, delta x is a very small value of x. Okay, you remembered like that, it is a very small increment in x. So suppose x is 5, this is 5 plus 0.0000, something very small. Okay, so even this looks very big, but actually delta x is very small. Same goes for delta y. So you have to somewhat think that delta x and delta y are very small quantities, right? Now what will be the slope? Suppose I draw a line which joins p and q. So what will be the slope of the line? Slope of line pq. Now you all agree that this is a straight line, so slope is nothing but rise by run, or what we say perpendicular by base, or if you guys remember, it's rise by run, which is nothing but tan theta. Okay, so what we are going to do, we are going to make a small triangle here. So this has a length delta x, and this part has length delta y. This is rise, this is run. So slope of line PQ is going to be delta y by delta x. Okay, now this is slope of the line which is connecting P and Q, and if you make it, let us say this angle is theta, then this is also equal to tan theta. Now what Newton did was very amazing. He asked the following question: what is the slope at point P? Okay, so what is the slope at point P having coordinate xy? Okay, so he asked this question. Now what he did is that he assumed, he asked this question, that what will happen if delta x tends to 0. Now tends to 0 and 0 is very different in calculus. So tends to 0, we write limit, okay, limit delta x tends to 0. So what will happen here? He asked this question. Now let us try to understand it. If delta x tends to 0, so this part, as you make delta x smaller and smaller, so what will happen? This q will now shift, right? So this part will start shifting, and when delta x tends to 0, this part is squeezed in this portion. Okay, so this point q will overlap with point p. Okay, try to visualize that. So this idea, when limit delta x tends to 0, means that this delta x will get smaller and smaller, and when this limit will valid, then this point q will overlap on this, because as you are making it smaller, this q will come closer and you will reach this point. Now what he did, that he said that when you make delta x tends to 0, then you will have this situation where this was our point P, right? So if I draw a tangent, okay, if I draw a tangent through this point P, and let us say this angle is theta, don't confuse with this theta, this is different theta now. Now this point has a coordinate xy. Now if I draw a tangent, you guys know that tangent is a line which touches a curve at only one point. So slope at point P is given by this angle. I draw a tangent. So when you make delta x tends to 0, the slope of line PQ will become slope of the tangent at point P. So when you make this 0 tends to 0, then this idea becomes slope of tangent at P. Okay, now this idea is written as, if you have delta y, you have delta x, and if you take limit delta x tends to 0, this whole thing is written as dy by dx. So try to understand, this delta y by delta x is not same as dy by dx, but it becomes same only when this part is very small. Now that is one good part of calculus or mathematics, that you can divide anything into very small parts, okay, which will say is close to 0. So this is the meaning of this. If I repeat it again, dy by dx in yx graph will give you slope of tangent at a point. So in this case, whatever is dy by dx will be equal to this tan theta of this tangent. Okay, now moving on. Now this idea is used in physics because it was invented by Newton to explain physics, some parts of physics which was not explained, and what he formulated as called Newton's laws of motion. All the ideas are involved there. Now to just have an idea of dy by dx meaning, so dy by dx, rate of change of y with respect to x, can be positive, can be negative, and can be 0. Let us see an example of it. Okay, now let us say we have something which is going, which is a shape like this, sine curve or whatever. Now this is my y, this is my x. Now you can agree that this point I can call it maxima, and this point can be called as minima. Okay, so this point is called maxima, means this graph has maximum value here, okay, whatever is the value, and this graph minimum value is here, whatever is the value. So this is minima. If I ask you what is dy by dx at this point, let us say this point is P and this is Q. So to answer that, what you will do, you will draw a tangent. Now you can see dy by dx slope will be 0 here. Okay, same way I can draw a tangent here. So since it is parallel, slope will be 0. So if you have any function at its maxima and minima, dy by dx is 0. Why it's 0? Try to understand it at maxima, minima. Again I am saying why it's 0, because the tangent slope will be 0. So dy by dx is 0 here. Now if you take a point here, let us say we are calling it A, and if I draw a tangent at this point, you can see this is the slope of this tangent. So at dy by dx will be positive for point A. Why? Because tan theta will be positive, right? Now moving on. So if I take a point here, let us say B, whether its dy by dx is positive or negative. So for that again you will draw a tangent, and you can see that it will make a obtuse angle, means more than this is the slope, so which is going to be negative. So dy by this is positive for point A, negative for point B. In the same way it will be 0 at maxima. If anything reaches that thing, then it will be. Now just to give you idea how this maxima and minima comes into physics, if you throw a ball, let us say this is y direction, right? So if you throw a ball as it goes at highest point, means at maximum point, what becomes 0? So as you throw a ball at highest point, its velocity becomes 0. Now try to understand why. Velocity is nothing but dy by dt, in this case rate of change of y with respect to time. So at the highest point, y change will be 0. Otherwise, if it is not 0, then it will keep on going, right? So since y is a function of time here, right, dy by dt is the velocity, so at the highest point it is 0 because of this condition. Okay, don't get confused here. Y and x are just two variables. Okay, here you have y and t, so dy by dt will be 0 at this point. Okay, now moving on. Now next thing we are going to do, we are going to see some simple formulas which we used in you can say mathematics, physics regularly, and we'll try to solve some questions related with it. Okay, so I will just write it and I will try. So if y is some constant, okay, c will denote a constant, then dy by dx is 0. Okay, this is one result. What I mean by that, if you have a graph yx something like this, let us say, so y is a constant, there will be no change of y with respect to x, so it ought to be 0. Okay, there is no change in y with respect to x, that is the meaning. Next, if I have y equal to x to the power n, then this dy by dx as a general formula, that is nx n minus 1. Now to give an example, suppose you got y equal to x cube, then if you have to find dy by dx, use this, n is 3, so in this case dy by dx will be 3x square. Okay, nx n minus 1, so you will get this. Now third thing, if you have suppose y equal to c times xn, means c is a constant and like this. Now this, if I write dy by dx, c is a constant, nothing will happen to it, so it will be d by dx. I am writing on this side also c to the power xn. Okay, now this thing will give me dy by dx will be c is a constant, nothing will happen on it, and this one we know only x to the power n, nx n minus 1. Okay, now to give you a simple example, suppose y is something 6x cube and you find dy by dx, so dy by dx will be 6 will remain as it is, this will be x to the power n, so this will be 3 times x square, so this will be 18x square. Right, now of course you have to just remember the formula. Okay, now whenever we'll use any idea of differentiation, I will try to mention it in the lecture. Now just to take 1-2 more example, okay, I will just do 2. If y is sine x, then dy by dx is cos x. If y is cos x, dy by dx is sine x. Now sorry, minus sine x. Again, we don't have to know the derivation, you have to know the result. Now let me just take one example like this. Suppose y is something sine cx, where c is a constant. What will be dy by dx? So in this case you will find that first you differentiate sine, which is cos cx, and then you will differentiate this cx, which will give you c only. Okay, so its answer will be dy by dx equal to c times cos cx. Okay, now this kind of thing will encounter. Fine, this is called chain rule. You differentiate this, then you differentiate this. Now c is constant, it comes here, and dx by dx is 1, that's why you get that. Now moving on, in one dimension, as I told you, instantaneous velocity is dx by dt, acceleration is dv by dt. Now just see the value of acceleration. V is dx by dt, so same thing, a I can write, this is d by dt, this is v is dx by dt, right? So acceleration can be also written as d square by dt square. Now this is called second derivative of x. This is called first derivative, means you do differentiation once, you get this, and if you do differentiation twice, you will get this. Okay, we'll see an example out of it. Now moving on, let us take a simple example to just understand these things, whatever we have discussed. Okay, I will take, suppose I take an example, x is given to be 5 plus 2t square plus t, where t is time, x is position, and your question is find velocity and acceleration. Okay, now what is velocity? Velocity is dx by dt, so I am differentiating both sides with respect to time. Okay, so what I am going to do, since v is dx by dt, so I will differentiate both sides with respect to time. So I will write d by dt on this side, and I will write d by dt on this side also. Now try to understand. So same thing, I operated d by dt on both sides, right? Now this will give you dx by dt. This thing will get distributed with these three things. So d by dt of 5 plus d by dt of 2t square plus dt by dt. Now don't try to cancel this. Okay, this t has power 1, so let us operate in the reverse way. So if you guys remember, if you have function like x equal to tn, then dx by dt will be n tn minus 1. Okay, recall that thing. So here t to the power is 1, so this will become 1, and t to the power 0, that becomes 1 only. So this will give you 1. Okay, so I am writing plus 1, this is the last part, it comes from here. Again the same idea comes here. This is constant, nothing will happen here. This is t to the power n, that is t square, so that will become 2 remains here. This will give you 2 n t n minus 1, 2t 2 minus 1, that will give you t only, plus differentiation of constant with respect to time. 5 is a constant, nothing will happen, so it will be 0. So your answer to this velocity will be 4t plus 1. This is the velocity at time t. Now if you ask what is the acceleration, then you know that acceleration is dv by dt. So again I will differentiate both sides with respect to time. So dv by dt, this side also d by dt comes, and 4t plus 1. Now if you operate it, then this is acceleration d by dt of 4t plus d by dt of 1. Again differentiation of constant is 0. This is 4t, use the same concept as we involved with t to the this t has power 1, right? So you will find if you operate by the same way, then you will get this to be 4. So acceleration is 4. So you can see acceleration is not a function of time, so it will be termed as a constant. So acceleration is constant in this case. Okay, now let me quickly take one more example which you guys are familiar. You guys have all seen this equation, x equal to ut plus half at square, right? So if I differentiate both sides with respect to time, what I will get? I will get this to be dx by dt, and this is d by dt of ut plus half at square. Now this will become d by dt of ut, and half is constant. Okay, let me write it together, d by dt half at square, right? Now you all know that initial velocity is constant. As we launch anything, its initial velocity is constant, so you will come out, so this will become dt by dt. We have done dt by dt earlier, it's 1 plus, in this equation is only used when a is constant too, right? Initial velocity is constant, acceleration is constant, so we get here half a is constant, it comes outside, you have d by dt of t square. Now this is t to the power 1 and this is t to the power 2. If you guys can do this, this gives you u, this is half a, t square, do nt minus this, so it will give you 2t. So if you 2 get cancelled and dx by dt is velocity, so we get this relation v equal to u plus a. Okay, now before I finish, the most when we use vectors, okay, vectors are not like one dimension, it is 2 dimension or 3 dimension. In vectors we use position vector, then okay, this is position vector, so velocity is defined as, in vector notation, dr by dt. Okay, rate of change of position vector, this is about 2 dimension notation, and this acceleration will be dv by dt, and going on by the same way, acceleration can be written as d square r by dt square. Now let me end with this, that the famous equation of physics, which is called F equal to ma, right, force equal to mass into acceleration, without vector sign, let me write, this is written as md square x by dt square. Now this is the representation of Newton's law in differentiation, F equal to ma, and in vector form its representation will be like this. So just you have to know the basic of it. I guess you guys followed this, and whenever we'll use this concepts, I will try to put the things again in order. Okay, thank you, and I will see you in the next video.